Mathematical models of growth and decay describe how a quantity changes over time, either increasing or decreasing. These changes are often modeled using first-order differential equation expressed as dp over dt equals to kp, where k larger than 0 indicate growth and k smaller than 0 indicate decay. Showing rate of change is directly proportional to the current amount. Our study focused on Panama, a rapidly developing country in Central America. From 1993 to 2012, Panama's population has grown steadily due to urbanization, improved healthcare, and economic development. The study is conducted to model graph and analyze the population growth of Panama using first-order differential equation as well as predict both past and future values based on the available data obtained. This allows us to analyze the trend caused the implication of population growth in Panama.
From year 1993 to 2012, the population showed steady growth. Starting at around 2.6 million in 1993, it increased by about 50 to 70,000 people each year. By the year 2000, the population had reached just over 3 million. This upward trend continued through the next decade, surpassing 3.5 million in 2009. By 2012, the population had grown to approximately 3.76 million, marking an increase of over 1.1 million people in just 20 years. This chart shows a clear upward trend in population over a 20-year span. Starting at about 2.6 million, the population steadily increases year after year, reaching nearly 3.8 by the end. The growth appears consistent and linear, showing its steady development without major dips or spikes. I will show you a calculation on the next slide. Let's explore how Panama's population growth can be modeled mathematically. We define PT as the population at time t in years. According to the model, the rate of population growth is proportional to the population itself, a classic exponential growth scenario. This gives us the differential equation dp over dt equals to k, where k is constant proportionality. To solve this, we separate the variables and integrate both sides. We get ln p kt plus c, which leads to the generic solution p equals to a exponential kt. Using the data from 1993, where t equals to 0 and p equals to 2.6 million, we solve for a, which also equals 2.6 million. Then using data from 1994, where p equals to 2.6 million, we plug into the model to solve for k, which comes out to approximately 0.0206. So the particular solution becomes pt equals to 2.6 exponential 0.0206t. This model can now predict Panama's population for any year t after 1993 using exponential growth. By using the particular solution, now we can predict the future and past value. We use the particular solution to predict future value in 2024, which is we predict it to 4.9 million. And for the past value, we predict in the year 1990, which becomes 2.4 million. By using also the particular solution, we can also calculate percentage error. We get our percentage error is 0.344509%, which is quite small.
One of the major causes for these differences to occur would be the political stability in Panama. This factor is why many people in Latin America prefer to live as citizens in the country. The political stability in Panama promotes good security and quality of life for its inhabitants. Due to this, developments for the economy also a main factor why many people prefer living in Panama, and simultaneously helps to increase the population of Panama ever since focus has been placed on it since 1990. Furthermore, healthcare improvements and modernization are also another reason for the population to increase. This is because investments in healthcare can help to improve life expectancy and reduce infant mortalities. The population growth in Panama is also influenced by education and urbanization. Panama has been concentrating its population in urban areas and increases access to more job opportunities and services for its citizens. There are several reasons why our model's accuracy is not perfect. One of the main reasons is that we assume Panama's population would grow at a constant rate. This doesn't exactly reflect how population growth works in real life. Many external factors can affect how fast or slow a population grows. This includes people migrating, health issues, political stability, natural disasters, and economic changes. The future of Panama's population could also be changed due to multiple factors, such as introducing new government policies, precautions against natural disasters, development in technology, and migration from neighboring countries. The first factor, which is government policies on infrastructure and economic development. The Panamanian government invested in infrastructure projects to mainly address environmental challenges. Example of it being the project proposed to secure freshwater supplies for the Panama Canal amid the increasing droughts around the country. Next, the Panamanian government also proposed for the Guna community on Gadisugdu Island to be Latin America's first organized climate migrants, relocating due to rising sea levels and overcrowding. This project would affect approximately 38,000 residents. There is also a huge decline in birth rate for the country, in which decreased by a lot in 2025. Due to this and other multiple factors, the government will be investing a lot in technology development for healthcare and other industries such as infrastructure and education in recent years. Due to Panama's strategic location and economic opportunities, it makes it a destination for migrants from neighboring countries. Although many view that migrants can bring both pros and cons to their country, but by introducing effective integration policies, can they ensure social cohesion and economic stability amongst the citizens?
In conclusion, we have successfully achieved the objective for Task 1. This allows us to apply and understand the concept of first differential equation learned from the MAT098 courses for our assignment. In Task 1, we applied this method to calculate the gross population in Panama from 1993 to 2022. From the predicted value calculated, we managed to find the percentage error using actual value minus estimated value divided by actual value. By comparing the answer, we found out that the values are not the same and found the reason for it. Other than that, we successfully determined the factor influencing the gross population in Panama from 1993 to 2022. All in all, because of Task 1, we gain many benefits that can help us understand the gross population in Panama better.
Now, me and Emily will present Task 2, Application of First Order Differential Equations.
This is the following question given by the lecturer, which is to integrate the following function from x equals to -1 to x equals to 1 using Simpson's rule, with 7 and 9 ordinates. Answer should be in 4 decimal places.
Simpson's rule is a method for approximating the area under the curve by using parabolas to get a more accurate area under the curve. The requirement for Simpson's rule is to have an odd number of ordinates so that we can get an even number of subintervals, because in Simpson's rule we have to calculate the area under the parabola by using 3 points, which is a pair of subintervals, and which is then tallied up to find the total area under the curve. Presented is the formula for Simpson's rule, where h is the width of each subinterval and y0 and yn is the first and last ordinate. Odd positioned intervals are multiplied by 4, whereas even positioned intervals are multiplied by 2. xi is the position on where you will evaluate the function.
For n equals to 6, we calculate the h value using the h formula, which is h equals to b minus a over n. Then we plug in the values into the formula, which we will get h equals to 1 minus -1 over 6 equals to 1 over 3. And in order to calculate the xi values, we use the xi formula, which is xi equals to a plus I times h. Then by using Excel, we plug in the values of I, which is from 0 until 6, and then Excel will compute the values for xi, fxi, and weight. After that, we use the Simpson's rule formula, and we will get the area, which is 6.5755. Lastly, we use a graphic calculator called Desmos. We use it to calculate the area of the graph, and we obtain the value of 6.5659. While if we use n equals to 6 to calculate the area, using the Simpson's rule formula just now, we obtain a value of 6.5755. Since there is a difference in the values of the areas, we calculated the percentage error using the formula, which is percentage error equals to the actual value minus calculated value over the actual value times 100%, and we will get 0.1462%.
Now for our n equals to 8, much like n equals to 6, we found the value for h, which is 1 over 4, and we input the formula for xi into an Excel spreadsheet to generate a table. The values from the table along with Simpson's rule was formulated, and we added up the values to find an area of 6.5682. Now, with the area that we got from Simpson's rule, I'm going to compare it with the area that we got using the graphic calculator. I did procedure to count the percentage difference, and then I got a percentage difference of 0.035%. Thus, we can compare the two percentage differences, and we find that more subintervals equals to more accurate area, because using more parabolas gives you a better fit.